everyone. This is the video on the fourth video in the Unit 1. This time we are going to be focusing on physical and chemical properties and physical and chemical changes. Here we've got kind of an elaboration from the last video where we're going to look at how matter, what the properties of matter are, and then how those can be used to really define matter. Now, when we talk about physical properties are anything that can be observed without changing the chemical composition of that substance. So like here we've got a glass of ice that is melting into water. It's still water, it's just no longer frozen. And so we can talk about melting point, we can talk about freezing point or boiling point. You're changing the phase of matter but not what the matter is itself. If you talk about malleable and ductile, malleable means you can bang it with a mallet and stretch it out kind of like aluminum foil. Ductile means you can pull it into a wire or a duct, kind of like copper wiring. Magnetic properties, it means it's either going to be magnetic or not. We actually talk a little bit about paramagnetism later. Texture, it can be smooth or rough. Color, density, it's how much of something the mass in a volume, okay? And then mass is just mass, or we even call it weight sometimes. Now, these properties can be either intensive or extensive. Intensive, extensive. Now, the way that I kind of view this is when we say that a property is extensive, okay, it means that you really have a property that it depends on the extent or amount. Intensive property is going to be the same no matter how much you have. So it's independent of the amount. Okay, so if we look at, I'm sorry. Sometimes I put my arm down too hard. If we look at mass, mass is definitely going to be extensive. It depends on how much you have. Your mass is going to change. You know, you're going to weigh more after Thanksgiving because you eat more after Thanksgiving. Density. Believe it or not, guys, this is an intensive property. Think about styrofoam for a second. You know, if you put styrofoam on top of water, it's going to float. It doesn't matter if you have a ton, literally a ton, of styrofoam. Its density is going to remain the same. It's still going to float on water. It doesn't matter. I mean, think about the boats that float. Those things weigh, you know, hundreds of thousands of pounds. Color. Generally, you know, I guess it kind of depends on if we're talking about solution or a solid. But for a solid, we could say that this is, you know, independent. A copper penny or, you know, a ton of copper is going to have the same color. Texture, again, this is kind of an intensive property. Magnetic, intensive property. If you don't believe me, go get a magnet, put it in a Ziploc bag, shove it into a bag of cereal. Crunch up the cereal. It's got to be kind of crunched up. But the cereal will stick to the magnet because of the little chunks of iron that are in the cereal. Especially if you get something like, Total or, shredded wheat really would have to be like kind of crunched up really well. But there's a ton of iron in that. Malleable and ductile, again, intensive. Water is going to freeze at 32 degrees Celsius, 32 degrees Fahrenheit, or 0 degrees Celsius, regardless of whether you have a small ice cube or, 15 foot of snow. It's got the same freezing point, okay? Now, physical properties can be used to purify mixtures. Okay, kind of think about this in terms of size. You know, if you wanted to filter out, you had sand and water, you could filter that sand out of the water by running it through a filter paper. It takes advantage of size. So filtration deals with either size. It can also deal with, well, we'll talk about that later. But filtration is pretty much going to deal with size. Solubility. This is a physical property that determines whether something will dissolve. Usually we're going to talk about whether it dissolves in water, but when we get to the organic unit, that'll change a little bit. And so we'll talk about solubility. You can use chromatography or even just adding in a solvent to try and remove something. So like if you had salt and sand you wanted to remove from each other, you know, salt and sand are the same size, but what you could do is you could add some water, the salt will dissolve, sand would not. Once you have the salt dissolved, you could take it off as salt water and then evaporate the water off. Sublimation, kind of the same as like, you know, melting point, boiling point. Here we've got a property where the phase of matter is going to change from solid directly to a gas, and so you could separate different things based on their sublimation point. Think about dry ice. You can still get those usually at grocery stores for shipping. It separates that solid CO2 out. It turns immediately to gas, and you end up having what's left behind. Distillation, this is how they purify you know, crude oil. They put it into a kind of a crude picture here, but a furnace. They start to heat it up at very low temperatures, like room temperature. Just gases like oxygen, nitrogen come out. A little bit hotter, the part that we use for gasoline, you know, pentane, hexane, octane, those come off. Heat it up a little bit more, you get the components for kerosene. Heat it up some more, you get the diesel oil. Then you get fuel oil for like jets and so on. And then at the very end, you're left with like a solid lubricating oil, like that petroleum jelly, the stuff for asphalt and so on. Chromatography is awesome. If you watch any crime shows, they try to really play this up. What they have is, and you can't really see it here, but you have a column that's got a matrix inside. And what you do is you run your sample through that matrix, and depending on the solubility, different components will come out at different times. And so if you wanted to purify a protein or a marker or a, you know, even a metal, you could really use that column to purify based off solubility. Okay, so physical changes take advantage of those physical properties we just discussed and allow you to have, I don't think I turned down. Yep. They allow you to take advantage of those, come on, those physical properties, and you can have a change while still keeping the chemical composition. Okay, so something like cutting a piece of paper. It's still a piece of paper, it's just now smaller. You can melt ice. It's still water, it's just liquid, not solid. Freezing, boiling, dissolving, these are all things that keep the substance the same. It's going to change the property, but it's still the same chemical composition of that substance. Here we have a gallium spoon. This gallium melts at about 86, 87 degrees Fahrenheit. It looks like a spoon. It's a metal. Well, it's really, you know, it's a metal, but it's right next to the metalloids. It sounds like a metal. It looks like a metal because it's shiny. But when you put it in warm water, it is going to melt. Now, it's still gallium. You can kind of see it down there in the bottom of that video. But it's no longer solid. It's now a liquid. And so the idea is we have changed the phase of matter, but we have not changed the chemical composition of that atom. Now, if you were to take that out, you know, and put it on the table or to remove the hot water, and don't try this at home, you're going to get the gallium metal is going to re-solidify. It's going to be solid again. It's just not going to be in that shape. Chemical properties, on the other hand, do alter the chemical composition of the substance we're talking about. And really, we're going to limit those right now to whether you burn it, you react it, or you oxidize it. And you burn a forest, you burn a tree, that tree is not able to return to its unburned state. You can grow a new tree, but that tree is done. It's not going to be able to return to that original state. When you oxidize something, a chain or bridge, the steel gets oxidized. That you can't unoxidize that chain. It is now a new chemical composition. It's no longer iron or steel. Now it's iron oxide, and actually probably this form instead. So when you have oxidation or flammability, some type of reaction going on, you have a new substance with new properties. So let's just look at this really quick. Are these physical or chemical properties? You burn, again, pause this, kind of think through it. A log burns in the campfire. You can't get that log back, so this is going to be a chemical change. Toasting marshmallows. Now, I always have somebody say, well, it could be physical, you're just heating it up. Yeah, but if you've ever, burned a marshmallow, you can't get that black stuff to go back to the uncharred marshmallow, so this is a chemical change. Dissolving sugar in your tea, this is a nice physical change. Boiling water, it's still water, it's just gas phase, this is physical. Cooking pasta, again, this is one of my challenge questions. I love this question. You put pasta in water. Most of you are like, oh, well, you can just, when it's done cooking, you can leave it out. It's going to harden. It's going to re-solidify. That's true. However, pasta contains egg. Can you uncook an egg? Think about like a cake. Can you uncook a cake? I'll put candles on there. This is going to be a chemical change because it's going to cook the egg in that pasta. Raft floating or something like that in the pool, this is again a physical property. Okay? That concludes this video. Thanks for watching.